Welcome to our first official robot software class where we're actually going to be learning a few things about software. Um, and today, basically, we already generated an empty project, right? We got literally only two classes. What is it? If you go in your IntelliJ, I'm going to be preferably working IntelliJ. You should see main and robot.java, right? But the thing is, if you were to open and look at them, not only this should look kind of foreign to you, and if you just came out of a Java software class and you don't have much experience writing Java in this kind of a scenario, it probably looks a little bit overwhelming. So that's why today we're going to be taking a little bit slower. We're going to be slowly going over what we already see on our screen, main.java and robot.java. And we're also going to be trying to write a subsystem, a very, very simple subsystem that sort of mocks the way that we do subsystems in our official code, but we'll probably start jumping into that sometime next week. And getting you guys into the idea of how can we manage joysticks and how can we do some work with them. And in general, how do you manage data and how the actions are carried out on a robot. And finally, we'll try to run this code and see some console outputs in the simulator. So hopefully today will be pretty fun. Okay, so for now, I'm just going to be sharing my screen and we're just going to have you guys follow along with me. And what we're going to do is I'm going to try to give you guys an assignment later today at the end of the class, kind of sort of like a homework and such or practice. And I'm thinking of trying to schedule a time. I'll put up a poll sometime soon in the Slack channel of when you guys would like it, like for a second meeting where we can go over homework if someone is really, really stuck and has no clue how to proceed with the assignment I give you guys, etc. So it's kind of like a general review. It's not going to be a formal class. You guys aren't required to come. Anyways, let's see. I hope you guys right now can see my robot.java. And for now, you guys can go ahead and just watch directly on my screen. I don't think you guys need to have IntelliJ open right now, but eventually we'll be writing some code and I'll have you guys follow along, okay? So, let's see. Okay, so let's go ahead and take a look carefully at main.java. If you guys remember correctly, you know how,
Samuel,
yes?
the text is very small on our end. Yeah, that's much better.
Yeah, I have to remember to zoom in for every single file I'm in. Okay, but either way, if you should remember how I said that every Java project has one main function. So in order for the code to start running, you need like an entry point, right, where the code starts executing. And when we're doing robot code, we start in this main class. Okay, so first of all, you might have noticed that okay, that's a little bit small. I think if I shrink the window, things will just automatically look bigger. You guys might notice on the left side how the packages are already organized. Okay, so we're already following the standard of com.team 2813, where team 2813 is standard start package names of com dot. And then we have a package, FRC, right? This is where we're going to be putting most of our robot code. And then we have another package called lib, which we'll handle later. And then right now, we're just going to be focusing on main and robot. And main is where the code starts when you actually run the robot. So when you power on the robot, it's RoboRio boots up and everything. This is where the robot code starts executing. Okay. And then you might be familiar with this, right? Public static void main string args. I think this is something that most people uh, most people are familiar with. Basically, when you run the Java project, this is where the code starts. Oh, and one thing I forgot to mention is right now on the left side, I only have FRC, and that's mostly because of the fact that this robot or this project isn't necessarily tied to any year. There's a possibility that the software team next year might decide to use this project, but right now it's just FRC. Otherwise, it could be FRC 2020, like we did last year, or if we had a build season this year, we would probably name the package FRC 2021. Okay. Either way, let's go and take a look at this file very quickly. Let's start from the top to bottom. Okay. And so first of all, because it's an auto-generated code by first, we have a bunch of comments here that they tell us about what it is. This is kind of standard coding procedure, okay? So you can see obviously just the copyright, we can skip that. Obviously, package, declaration, this is normal to Java, right? This shouldn't be alien to anyone. And then here we're going to see our first use of an external library. And if you go to build.gradle, zoom in a bit, you can see here that we have a plugin. Okay, so we're telling Gradle to use the Gradle Rio plugin, which is I think something that First officially sponsors now. And then there are also these, yeah, do you see these dependencies here? These dependencies mean we're basically going to be using libraries that WPI-lib gives us to work with. Okay, and so that and so now we're importing robot base. Okay, so that belongs to edu wpi first wpi libj.robot base. Don't worry, the reason why we use IntelliJ is so that we don't have to memorize these. There will be an auto import feature, or at least a feature where you can import and it'll automatically slap that onto the top of the file. And obviously we have a private constructor here. The idea is that, and you can see here, do not add any static variables to this class for any initialization at all. Unless you know what you are doing, do not modify this file except to change the parameter class of the start robot call. And that's as simple as that. So basically, when you run public static void main, when the Java code starts, it's gonna create a new version of the robot. Okay, I believe this robot, yeah, this robot.java is the one that we have in our project. Okay, is going to create a new instance of the robot, and this is like a Java 8 notation. The equivalent will be something like this. No, not reboot robot. Okay, but again, we're just not going to touch this for now. Either way, it imports robot base. It calls the static method start robot, and we pass in a robot. I think it can get pretty simple, right? All the main function does is really make an instance of a robot and then start it, pass into a method and start it. Okay. So now that's literally it for the main.java class. This one and sole reason right now is to just simply make sure that the robot starts running.
Right. So this is the only place we have a main method in the entire project. So you can kind of think of this is where it starts and then it goes everywhere else. And it says unless you know what you're doing, but even if you know what you're doing, you should never have to change this file.
Exactly, that's correct. And you will see this file in every single one of our projects, and it will be probably literally the exact same unless there's a project out there that was generated before 2018. Anyways, let's go ahead and talk about robot.java then, the second file that was automatically generated. And let's go ahead and do the same thing again. We're going to go from top to bottom, and then we'll get into the details of what this file actually means. So you can think of robot.java as sort of a little bit of of the heart of all of your entire robot's code, basically. And I'll explain what that means later, and I hope it will make sense later. But basically, it connects all the systems that you're going to be doing with it. So first of all, we're going to see here that we're using even more WPI libraries. That's just a given case. They give us a lot of tools that lets us work with the Roborio, Roborio and a lot of their utilities and whatnot. And obviously, we're importing timed robot. You might have noticed that is the class we're extending, and it's also the type of robot that we wanted. And also, these two classes from Smart Dashboard. This is just a way to report things. Well, I'll go over them in a later class. Anyways, let's go and read this comment really quickly. The VM is configured to automatically run this class and to call the methods corresponding to each mode, as described in the timed robot documentation. If you change the name of this class or the package after creating this project, you must also update the build.gradle file in the project. Okay. So basically, this is probably where most of your code is going to start. And let's see if that is mentioned here. Yep, you can see here that it's telling it to keep track of where your robot main class is, and that is declared up here, right? Okay, and your main class is here, and obviously the main class generates a version of robot. So in essence, this class will be ran when the robot starts. That's really all it means. We have a few constants here. We're not going to touch it for now, but you can say this is just a string, default auto, custom auto, right? There's another string here called auto selected. And then sendable chooser string chooser equal new sendable chooser. I really don't want to talk about Smart Dashboard right now, but simply put, this puts a graphical drop down on the driver station, the computer that you control a robot with, like that you plug joysticks into and whatever. It lets you choose like your auto mode or whatever. We'll gloss over it for now. Okay, so I think right now this class has about, let's see, 1, 2, 3, 4, 5, 6 methods. Okay, And the way timed robot works is the reason why it's called timed is that it has these functions that are called periodic functions that are called a set number of times per second. That's why it's timed. And that times a second is 50. Okay. It's gonna be called 50 times per second. And Yash, you're asking why we override the methods in the robot class. I'm gonna get to that right now. Okay. So I think it might be worth diving into the timed robot original class that we're extending from, just to kind of take a look at what's going on here. Okay. So when you see here, when you make a timed robot, you have to pass in like a period and there's this, and you can see here k default period. And what that means is every period is going to be 20 milliseconds or 0.02 of a second. And you can, if we take a look into iterative robot base, you can see there's a lot of layers to this extent. You can see all of these functions, okay? You see, and it's a very distinct pattern here. You got robot init, you got simulation init, disabled init, autonomous init, teleop init, and then you got robot periodic, simulation periodic, and disabled periodic, okay? And these methods are called by, I believe, yeah, it's called by iterative robot base every 50 times every second. So the init only runs once when you enter a certain, how do I put it, like a stage of the robot or like a
Mode or
status,
state.
a mode. Yeah, that's right. And the periodic is the one that's going to be called 50 times per second. Okay. So let's go to and look at the most simple ones. We're going to think about robot, autonomous, and teleop, because those are likely the states that we're going to be in, right? Well, either going to be just a robot standing there disabled, right? Or we're in autonomous mode, or we're in teleop mode. Okay. So the robot init method, okay, the robot init method gets called when the robot initially boots up. It's kind of the first thing you do in the morning. This is what the robot does the first thing it boots up, and you can put in some initialization things here. For example, let's go ahead and load some files that we need for autonomous, or let's go ahead and um, initialize a few classes that we should have before the periodic things get called and whatnot. Okay, so then it's the very first thing that gets called. Okay, and the robot periodic is just going to be called 50 times per second. And this is going to be called when the robot is just whenever it's powered on. That's what's called robot periodic. And so you can put things in here, for example, like if you want to be constantly keeping track of the temperature of your motors, this is where you can do it. Or if you want to be constantly keeping track of where your joystick is for whatever reason, you can do it here too, okay? So basically this will be called 50 times a second. All right, and I'll go over later why that's very useful. And then the same kind of idea works with autonomous and teleop as well. So when you're actually operating the robot, you're gonna have a little window, like a control window on your driver station. And basically you can click teleop or autonomous, right? And when you click teleop, it's gonna go into teleop mode. When you click on autonomous, you're gonna go into autonomous mode, right? And then you press enable and things happen, right? The moment you click on autonomous and you enable, it's going to call autonomous init. So for example, if we click on autonomous and we press enable, maybe we should quickly load up the file that corresponds to the autonomous that we want to run. And then autonomous periodic will be called 50 times per second. And this is when we can maybe make the robot move. Same with teleup init, okay? Teleup init, maybe there are a few things we need to initialize. For example, our control scheme, for example, we should get that ready. And then teleup periodic, where are you? Teleup periodic, because it gets called 50 times per second, we will read the joystick control 50 times a second and then change the motor speed 50 times a second. And that responds to joystick input. So that's kind of what, that's kind of how timed robot works basically. You have init and periodic methods that gets called at different points of times. And that's what can let us do stuff, okay? And if you've ever used an Arduino before, this is kind of similar in that you have I think you have like a run method where you like initialize your pin outputs and whatnot, and another loop method I guess called over and over again. And if you want to read a button, you just read the button's status every like X amount of times per second. Same deal with the time robot here. If we want to make the robot move based on a joystick movement, we just read the joystick 50 times per second, and then the value will just change as you move it. right? It's like a pulley. It's like, and that way we can make the robot do stuff. And Yash, you asked why are we overriding the methods in the robot class? The reason is because if you're going to iterate robot base, you can see default periodic method overriding. That's because the method exists and you might want to do something in this method, so just overwrite it. There's no harm in doing it, and it literally, this is how you want to do it, okay? So you can see here, let's go and take a look at the code that the BPI lib already auto-generates for us. So here we're overwriting robot init, and we're going to be doing our own init code, right? So remember, this code starts, and it says it here, this method is run when the robot is first started up and should be used for any initialization code. You can see here, we're giving that dropdown that I mentioned earlier, right? We're giving it a default option, and then we're telling it, hey, let's go and display this dropdown, okay? Thank you, Grady. So if you guys ever want to have a key, if you guys ever need a key of what it is while we're going through, well, there you go. That should remind you. All right, let's go and take a look at the next one, it overrides, and I'm not really sure why they left this empty, but it is empty. Let's go and read the comment. This method is called every robot packet, no matter the mode. Use this for items like diagnostics that you want run during disabled, autonomous, teleoperated, and test. This runs after the mode-specific periodic methods, but before live window and smart dashboard integrated updating. Okay, let's go ahead and break down this comment here because it actually has more than you think. So first of all, this is what WPI lib thinks is its main purpose. Okay, use this for items like diagnostics that you want ran during basically any mode. Okay, and like I said before, if you've been on last year's team, you might have heard a few things about maybe motors overheating, like we wanted to keep track of the motors, or what the gyro is like, you know, as we push the robot around, how the gyro position updates and whatnot. And those are like diagnostics that we want to know always, right? We want to know if our motors have cooled down enough or how quickly they cool down, no matter what mode they're in. And so, for example, I'm just going to write like kind of pseudocode. I'm going to be like motor dot get temperature, right? And then system dot print line motor dot get temperature, right? When I call motor dot get temperature, I'm going to get the temperature of the motor. And I'm just going to print out to the console, and this is going to be constantly printing out to the console 50 times a second, and will tell us what the temperature is constantly, right? It's a way to do diagnostics. Using console is a crummy way to do it, but for now, for the purpose of trying to understand this lower level robot code, I think it works perfectly fine because it teaches you how code is executed in what order. And speaking of order, this is the next part that might be worth paying attention in the future when you yourself personally wants to lead the code and develop something a little bit more complex, okay? And it specifies here, this runs after the mode-specific periodic methods, but before live window and smart dashboard. Okay, what that means is basically, if we're in autonomous mode, right? Autonomous and periodic and robot periodic are both going to be called 50 times a second on the same interval, but autonomous periodic will always run just before robot periodic. Okay, and if I'm not sure how you can use that information right now, but just if you want to do that in the future, do something with that in the future, that could be something to do.
For example, if you were updating something in autonomous periodic that you then needed in robot periodic, it would be helpful to know which one runs first.
Right.
However,
yeah.
in practice, given it runs 50 times a second, if robot periodic didn't get it until the next 1/50th of a second, you'd probably be okay.
Mm-hmm. And yeah, Sanvi, that's exactly right. The robot periodic will get called slightly after all of the methods. Okay, so let's go ahead and paint out a picture right now. Okay, so let's say user starts robot, right? So robot init is going to get called, right? Because that's the first thing it does when it boots up. And then while it sits there for a few seconds, robot periodic is going to get called a bunch of times, right? 50 times a second. And then when the user decides to enter autonomous, let's do teleop mode, right? So teleop init is going to get called, and then the periodic cycle, the periodic methods start getting called. Okay, and this happens 50 times a second. And it's sort of like a queue. There's a specific order to it. The very first one that's always going to be called is the specific mode periodic method. And in this case, because we're in teleop mode, that specific mode is teleop periodic. Periodic, okay? And then right after that, when teleop periodic finishes running, robot periodic will be called. So robot periodic will always be run after the teleop periodic method has finished executing for that specific cycle, okay?
And let me jump in for a second.
Mm-hmm.
Hold on, let me search for it again. Simulation periodic will run after robot periodic if you're in simulation mode.
Okay. And in simulation mode, the WPI loop simulation, is that what I'm assuming?
Yeah, the WPI loop simulation.
Cool. Okay, so that might, if we figure out that that might be something useful as we go along in these courses, we might actually end up us seeing use simulation periodic. But you can see how they've given us a lot of tools to make sure that we know which code should be running during what stage of the robot it's in. All right, let's go ahead and keep moving on. And now we're going to talk about autonomous init, okay? They give you an even longer explanation for this, but they're just really skimming over it. It's literally just telling you, use the smart dashboard utilities we give you and use them to choose the auto you want, blah, blah, blah. And you can see here, it's getting which autonomous mode you get, and it's printing it out. Oh, you selected this auto. This is kind of relevant to us right now, but basically autonomous init, you can do this stuff here. Worst part of software is the hardest part of software, but it can be very fun. Also frustrating. Right. Here's the big one: autonomous periodic. Okay, and you can see here that if you're doing a custom, autonomous periodic gets called periodically during autonomous. So when your robot is in autonomous mode and it's enabled, this method is going to be called 50 times a second, and Um, I'm not sure if you went to the autonomous briefing, but I don't think I got to talking about it. Basically, and since you guys are Java software people, I might as well just say now. Basically, the Ramsey controller, which is the library that we use, the low-level library that we use for doing autonomous, it gets called 50 times a second, and it basically tells us that if we feed it the path, if we give it how long autonomous has been running, um, Ramsey will give us the left and right wheel speeds, and then we tell the motor to change the motor, and that. So basically, the autonomous is changing 50 times a second, which is actually enough to make us do a quick path. 15 times a second is a lot, actually. All right, and then these are going to be the two methods, or not two methods, only one. This is going to be the method we're mostly going to be touching today. I wanted to see if we can read joysticks and play around with it. Now, if you don't have a joystick in hand, that's okay. If you do, you might as well go get them soon. I'll give you guys time soon. You guys have joysticks, but I can demonstrate on my computer. But basically, teleop periodic is for now where all the fun is going to be. Okay, teleop periodic is where you're going to be reading joystick inputs. You're going to be doing some math to the joystick inputs, and you're going to be putting them into the motor. You're going to be reading buttons, changing the status of subsystems, blah, 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 blah. I know I went really quick through that, but basically, teleop periodic is when you're going to be responding to user inputs, and you're going to be telling the robot to move based on those user inputs. So that's basically, and teleop periodic is going to be where a lot of the stuff happens, okay? And just to clarify terminology, because I haven't caught on yet, teleop means it means teleoperated. It means you're doing remote control, right? And then test periodic is during test mode. And I think you guys get the idea of periodic, yeah. All right. So far, are you guys feeling good so far about these two Java classes that we've got? And do you guys sort of understand how timed robot works right now? If you guys understand, give me a green check mark. And if you guys have any questions right now, you guys can go in and ask. And actually, I'm gonna go get my controller right now. If you guys have a controller, like an Xbox controller works. If you have like a Logitech controller, that should work too. If I think PS4 controllers work, but I'm gonna go get them right now. Okay. And I want, if when I come back, I want to see all of you guys have responded with yes or no. Okay.
If you guys have any questions, let me know. So there's a question about a mode-specific method. I'm gonna just share my screen here. So basically, we have things like autonomous init, which is specific to autonomous mode. Autonomous periodics also specific to autonomous mode. Teleop periodic specific to teleop mode. You could also have teleop init, and that is specific to teleop mode. Then test would be specific to test mode, and then simulation would be specific. That's not really a mode, but there's also disabled and periodic.
Mm-hmm.
So those are kind of the 4 modes there. Does that make sense? Okay, cool.
And like, you know what would be really useful about disable is that, for example, disable init, let's say when you disable it, you want to make sure that the robot, like for example, resets so that it will stop moving or whatever. You can do that there. And because there are times when the robot misbehaves and we have to panic disable, and it will be nice to have a little bit more safety in regards to that. And so all these methods, they will have a use eventually. Okay, so I'm going to be using the Xbox controller. I don't think I'm going to be using this controller over here, just because this is very standard. But you guys will see soon how this works out. And then, yeah, we'll try to get some code running on your computers. Okay, so let's go ahead and do the very first thing, and we're going to try to do a simulation. Okay, so I am going to have you guys follow along soon. Okay. So go ahead and take a look what I do right now, and then we can follow along, and then you guys can do what you want. Okay. So we're gonna be doing 2 things right now. Sending out a message that says robot has started. Okay, we're gonna be printing the console. Robot has started, and then when teleop is enabled, we're gonna constantly print out how much time has elapsed. Okay. So the way we're going to do that is, okay, if we want to do this, here, I'm going to text the goal into the chat. Oh, is my chat, where's my chat window? Oh, there we go. All right. So number 1 is we're going to get robot boot up when robot starts, print out startup message to console. Okay. And then when teleop is enabled, print out how much time has elapsed to console. And I want you guys to DM me the answer of whether or not of which methods we should probably put number 1 and number 2 in. Okay, they're different methods. Okay, but see if you guys can identify, and just DM me which methods you guys think belong. So is a robot in it? Is a robot periodic? Is it autonomous in it? Autonomous periodic? Where do you guys think 1 and 2 will go? So we got a few people who got one or 2 correct, and some people who got both correct. But a lot of you guys identified robot init, so that's a good job. You guys all said robot. Most of you guys said robot init, and that makes sense, right? When the robot starts up, that's when we're gonna be running that, because that's when the robot starts up, right? For number 2, this is in part my fault, but most of you guys, okay, half of you guys said teleop, but also the other half said autonomous. Okay, and um, remember, teleop and autonomous are completely different modes. So you can either be in teleop or you can either be in autonomous, but you can't be in teleop and autonomous mode in the same time, unless you're playing 2019. But that's a special case. You can't be in teleop and autonomous mode at the same time. So the answer to number 2 is going to be teleop periodic. Okay, so here, let me text the answer. Number 1 is robot init. Number 2 is teleop periodic. Okay? And so I'm gonna give you guys some options of what you guys want to do. On the robot init, you guys can get your intelligence ready. In robot init, we're gonna add a system.out.println line. Okay, we're gonna add system.out.println line and go ahead and print on the string, and go ahead and type in whatever starter message you want. You can say hello world if you want to be nice and simple, or you can say good morning robot, or whatever kind of message you want. I'm just gonna go in and put in this. Okay, but basically, go ahead and put whatever message you want, as long as it's uniquely identifiable that you put this in there. Okay, and then we're gonna go ahead and move on to teleop periodic. Okay, and then we're gonna go ahead and print out the elapsed time. And I don't want to bog you guys down too much with the algorithm, so I'm gonna go ahead and just do this right now. I'm gonna say elapsed cycles. Okay, maybe not specifically. Elapsed cycles is 0, right? And then time spent in teleop plus elapsed cycles times 0.02, right? Because every cycle is 0.02 seconds. And then I'm just gonna say cycle plus plus. Okay. And then if you guys can go in and copy paste this code if you want. If you think you can do something, you can change up the wording if you want, or change up the whatever. But basically, this is gonna make it so that whenever I went in teleop, it's gonna print out how much time you have spent during teleop, constantly 50 times a second, and we'll see that in action soon. Okay. So you guys can give me a green check mark when you guys have finished doing this. Yeah, it really does look pretty good. And I'm gonna go ahead and make sure that the code I have right now works in VS Code. But go ahead and start copying down what I'm doing. So here, for the sake of demonstration, I'm gonna move robot init and teleop periodic next to each other, so you guys can see at the same time. But remember, put anything you want here. You can modify algorithm or message too. Okay, so knock yourselves out basically. I'm gonna go see if this works. Oh wait, shoot, I forgot to unpause my screen share. There you go. It should update for you guys now. My bad. And give me a green check mark when you guys have done this. Okay. And if you have any questions, just ask in the chat. Yep. Okay. The code works. Oh, that's kind of cool. All right. It's always exciting to run code for the first time and see it work out. So the reason why I'm multiplying by 0.02 is because it's 50 times a second, right? So every cycle is 20 milliseconds. So if 50 cycles have elapsed, then 50 times 0.02 will equal to 1. So 1 second. Yep. All right. And if I'm correct, I believe Arkash just doesn't have intelligent VS Code set up. All right, let's go ahead and continue. Arkash, if you got any questions, because I know you can't touch code, but that's okay. All right, so now I'm going to go ahead and quickly revert this back. Preserve thy order. Okay. Now we're gonna go ahead and we're gonna check in this code into GitHub, okay, just to get you guys to feel. Hold on, how do I? Okay, we're gonna check this code into GitHub just to see how you guys would do GitHub, and then we're gonna run it in VS Code. Okay, we're gonna run the simulation. I'm running whole screen already. Go ahead and open up your GitHub desktop. Okay. All right, and you should see here that there's going to be a couple of this code changes. If you open GitHub Desktop and you're already in 2021 tutorial bot, you should see that there's one changed file, and there should be green lines of what code that you have changed. Okay, this is perfectly normal, and make sure to select the branch that you're in. I'm gonna make another branch called Samuel Teach. Okay. Bring my changes. Okay. Make sure that you're in your own respective branch. If it asks you to leave your changes or bring it with you, bring it with you. You want the updated code to go with you into the new branch. Okay, hold on. I think my GitHub desktop is really small right now. Let me go ahead and just share on the GitHub desktop. Okay, and then when you're done, go ahead and make a commit, right? So commit means basically kind of like pressing the save button and say, take a snapshot of like, let's stay in my current code. And we're gonna go and say, give it a nice message. For example, let's go ahead and say, started message in robot, start up message and elapsed time. Okay, so, and then do that. Make sure that you have selected the file, okay, that the robot.java is checkmarked, and then press, and then put in your message and you can press commit. Okay, Sambri, what do you mean by you can't hit the commit button? All right, we're gonna go ahead and open up VS Code, right? Share specifically VS Code. And if you remember all the headache that we had to do with the building and whatnot, you remember we clicked the top right, we clicked the WPI lib icon, right? And there's a bunch of stuff that pops up. If you type in simulate, you should get a simulate robot code on desktop. We're going to be simulating the code on our computer, okay? So for now, go and just take a look at my screen, and then you guys can try to do it on your own computers, okay? You can see here that when I type simulate, I'm going to select that. It's going to be doing a few things. Let's say executing tasks, going to be doing some Gradle stuff, right? So this is normal. And then once it's built successful, you see on the top again, it'll say pick extensions to run. And there should be only one. This is how sim underscore GUI, right? Go and check mark it and press OK. And you can see these debug and run menus come up. So if you want to rerun, like for example, if you change the code and you want to really quickly restart the simulation, you can press the green restart. You can press stop if you need to. So the green restart is kind of like deploying code. Stop is obviously kind of like shutting down the robot. I guess hot code replaces kind of the same thing, and you can pause it too. But when you do that, I'm gonna go share my screen. You're gonna get this robot simulation GUI. Whoa, looks techie and like a terminal and whatnot. Hacky, whatever. But basically, this is a simulation of a real FRC robot. And if we did PWM motors, it will show up. If we put in analog inputs, it'll work. Okay, so if you go ahead and take a look at VS Code really quickly, if you, I probably had that show up. I'll show you guys later. Anyways, if you guys scroll up, you guys should see a robot program starting line. And you guys should find whatever message that you decided to put in. Mine is 2813 is cool. You guys should be able to see it, okay? I want you guys to try to run the simulation right now and tell me if you guys have this message show up on your computer, okay? So we have some technical issues, and we're going to be going over the simulation part next class. The video will probably go during the weekend or whenever next class finishes. Bye-bye.